Question 3 is essentially asking us what's the length of a year for Mercury. If you're living in Mercury, how long does it take you to go around the sun? That's what they mean when they say what's the period of revolution. Period of revolution. For a planet, that's just the length of a year, right? How many Earth, and so a year is an Earth idea. A year is 365 days, but on Mars it is going to be a different number because it's going to take a different, you would define it differently. I mean, days itself is an Earth construct, so we don't want to develop a too geocentric model of the solar system. But right now, since what we know is days and years, we're going to use those units to refer to Mercury. Okay, so again, this is the same idea, the period. So we're going to use that equation that we had from the last question. AC equals 4 pi squared r over t squared. And remember that the radius in this case is the radius of the orbit of Mars. So this is Mars's, sorry, not Mars, Mercury's orbital radius, which they give in the question, right? And so they're asking us to just like to calculate the period. So we're going to rearrange this equation the same way we did in the last question, so that it's 4 pi squared r divided by AC, the square root of all that. So plugging what we know into the equation, we have 4 pi squared times the orbital radius, 5.8, times 10 meters, times 10 to the 10 meters, divided by, they give us the centripetal acceleration is 0.04 meters per second squared. We don't have units on any of those, so we'll just leave it like that. And when you do that, pause for a second while I calculate this. 4 times pi squared times 5.8 times 10 to the 10 divided by 0.04. Take the square root of that. And we get, okay, we get 7,562,121.395 seconds. So we want this in, you can see the answers in Earth days. So we're going to divide, so if that's seconds, to convert to meters. So that to convert this, I'm going to divide it by 60 to get minutes, and then 60 again to get seconds, and then 60, we want days, and then that's hours. So, sorry, 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day. I don't think I did this right. I'm going to have to... Oh, I did 87.5. So the period equals 87.5 Earth days. Again, a day is defined as the amount of time it takes the Earth to spin once on its orbit, on its axis, sorry. Obviously, Mercury's day would be different than an Earth day, but we're going to talk about it in terms of Earth units, because that's the kind of people we are. Thanks for listening.